And so the cold chain is essentially the infrastructure that allows something to be frozen at its manufacturing plant that allows you to go from source to your kitchen.
So even though the original cold chain was designed using liquid nitrogen, these days is much more likely to be dry ice, which is the solid form of CO2.
Can you put this specialized cold storage infrastructure onto commercial aircraft with a bunch of passengers and crews?
It turns out that CO2 presents some additional challenges and risks that have to be taken into account. Sublimation is when something turns directly from a solid into a gas, but CO2 as it sublimates, and that's when it goes from being a chunk of dry ice that's keeping your vaccine or your Dippin' Dots cold and turns into invisible, odorless carbon dioxide.
You have to be careful with the packaging that it doesn't create an overpressure, potential explosion, and packages are designed to alleviate the release of the gas. The key for aircraft transport is the quantity of dry ice you have and the volume of carbon dioxide gas that's coming out of the package or a number of packages, where you can get the level of carbon dioxide within the aircraft into an unsafe range. And that unsafe range would be, where you would be affecting the breathing abilities of the pilots and the crew, and it can also lead to potential asphyxiation.
So the cold chain makes sure that things that need to stay cold get from one place to another. What are some objects that you think need to travel on the cold chain? Let us know in the comments section. And if you like this video, be sure to follow STEM in 30 on Facebook and Twitter, and subscribe to the National Air and Space Museum's YouTube channel.